I think there were a lot of questions, controversies in the comment section, like going through the international news channels, all that. Going to the comment section, it was so controversial that people were now doubting. But what I keep asking myself is, in today's video, I'm actually going to be showing you what you should know about the 10 days NASA mission, which I'm going to be talking about in this video. And stay with me and watch the end. I've been seeing a lot of comments about people doubting the whole thing. So, but it actually makes me to wonder if we in this century and technological wise and all that, we are still doubting what's actually happening into this world. And many people are actually adopting the mission. AI is actually there nowadays to actually do everything, but that actually doesn't mean human can actually make everything possible. And according to the first mission of Artemis I, which actually took place in November 16, 2022, right? So there was not actually astronaut in the first mission. It was just like MC traveled to the space, whereby to just know what the space looks like. It actually lasted for 25 days, right? So what actually happened there was like just a survey. There was no landing, just like go travel around and see what's actually happening in the space and the orbit, all that. So, but I keep wondering how people, why are they kind of like adopting the whole thing? So I see people making a lot of video adopting the whole mission. Like, I don't understand. And I was wondering, how could human being this kind of like so wise, so brave to actually go about in a mission as this, right? Because if you look at it very well, it's not actually easy for someone that actually traveled. Or think about it, for people to come together. If we can have Concorde rockets, fighter jets, so why do you not think we can actually travel to the space? I don't know why people were actually doubting the whole thing, but you have to understand the fact that the first mission actually took place from NASA. So first of all, what is actually NASA? So National Aeronautics and Space Administration. So what they actually deals with is they actually deals with planes, jet, and like aircraft, all that. So it has to do with like space and aircraft and jets. So that's what NASA is all about, and it's actually a national thing which is actually owned by the US, right? So the first mission of the NASA was actually in about 50 years ago, which was actually Apollo 17, right? So that was the first mission of whereby they actually landed on the moon. But come to think about it, why is it not Apollo 17 or Apollo 18 this time around? So that's what you should be thinking about. You have the Apollo and the Artemis, right? So the Artemis actually means the goddess of the moon, right? Apollo and Artemis, they are actually twin sisters, right? So Apollo was actually the first, then the actually goddess of the moon. So Artemis is actually the twin sisters of Apollo, right? They are actually Greek words. So Apollo and Artemis. I think you've heard of Apollos before. You should be familiar with Apollos, and I don't know, I'm not actually a history student or all that, but if you know about Apollo, you should know about Artemis, right? So Artemis is actually a twin sister of Apollo, so which is actually the goddess of the moon. But that is not where we're heading to today. So we actually want to head deep into the mission entirely, which is actually Artemis II. And I'm actually going to be talking you through the day one, because I've seen a lot of people doubting the whole thing. But you have to understand the fact that there was no landing on the moon. It was just going to the moon to see what the moon is all about now after 50 years, right, of humans actually going to the moon. So there was no actually landing. So what actually happened on day one was that everything actually started at the Kennedy Space Center. The first mission was actually about launching the rockets, which actually have, let's see, within minutes they already reached the Orion space craft. So you should actually understand that the kind of speed that actually took them. But here is the thing: they are not actually going to stay in the Earth orbit. So they didn't actually stay in the Earth orbit for like that moment. They have, because they were actually going to be leaving the Earth orbit, because and that is outside Earth entirely, and which are kind of like the videos you see and the pictures you see and of what Earth looks like within those periods, right? So that is what you should understand. And on day two, that was when they actually leave the Earth, because first of all you have to understand the fact that they are actually not going to stay in the Earth orbit. They are actually going to leave, and there's what we call TLS. TLS is actually different. This is not about networking now, but this is actually a translunar form of like injection. I think this lecturer will know more about that though. So the spacecraft actually fires its engine, and there's what we call like translunar, which I actually talked about earlier, which is actually translunar injection. And from then, and just like that, they leave the Earth behind. So they actually leave the Earth behind at that moment, because you know, this is actually a journey of whereby you don't even know if you're going to return. So it's actually, this is the point of no return, so you have to move on. You can't really come back at this moment, right? So that was what actually happened in the day two. So that was day two, that is leaving the Earth orbit. Day three, that was actually where everything actually started. Now, that was where the whole momentum actually changed. And because at this moment, there's not actually communication, there's no clear communication. You have to test your communication. You know what it takes to be to test, because once you're outside, just imagine you are on Earth and you have communication delay sometimes, but just imagine now you're outside the Earth's orbit. So at this point, everything actually starts shrinking. Like the Earth becomes smaller, like a ball, like the globe that you know now. So it actually becomes like a globe. So this way astronauts begins to like testing system manually. And because in deep space there's not actually quick rescue, like there's no quick response like to rescue. It's not in this scenario, it's very, the rescue is very calm, like very timid. Do you get? And if you watch closely with the video, which actually stops now, you should see the video. I actually overlay on my video right now. So if you watch it very well, so this is actually the moment everyone was waiting for. At this moment, everyone was trying as much to wait to see what the moon looks like. So they were actually flying around the moon. One of the mission, Nolan, just a powerful reminder that we are going back home, like we're going back to Earth. So it was just like more like a survey entirely, I would say. But this time around, it's more than the first mission, which was Artemis 1. I remember I told you Artemis 1 and Apollo, they are both sisters, like twin sisters. So Apollo is actually the first mission of 50 years ago, which actually happened, and it was a success, right? So the Artemis is actually a reminder that human beings going back to the moon. So that was what actually happened in day 5. Outside the Earth, it's actually more like zero gravity. There's no gravity. Gravity is zero, right? So it's actually called like a free trajectory, basically like space physics, like saving life, like more like you making use of the gravity to fuel your space, right? Instead of making use of fuels. I don't know if you get him now. So they was actually, because I always talk about the free return trajectory. So that's what actually they make use of. So you have to be an astronaut and a physics student to know more about this, right? Though I'm not actually a physics student, but I'm just more interested in tech and this technology for real. So we have to talk about it. And day 8, so this is actually the most important days, and this one actually equals for survival, because it's more like you already get the mission, but now you have to come back to Earth to tell us what you've human endurance in deep space, like how human endures when you are in deep space, and human mental health, like mental health, and radiation exposure, like the Earth's radiation exposure to the moon. It's actually more like a future mission to Mars, because if definitely there's Artemis 1, definitely there's going to be an Artemis 2 and Artemis 3 at the same time. So we already have Artemis 1, then this is Artemis 2. So your mind should tell you now there's definitely going to be an Artemis 3. So maybe it's going to be about landing on the moon or going to Mars. So we don't actually know that one for now, but I'm pretty sure it's going to be about landing on the moon again, right? So yeah, that was what actually happened in day 7 and in day 8. Talking about the day 9 now, that is preparing for re-entry. So now things get intense, and everybody was, is it going to be possible? So this was the point that everyone was now freaking. So everyone was now scared. People are now in suspense mode, both families and everyone, even they're now returning to Earth to see your family, your loved ones, giving a report again. So this is one of the most important. Then talking about day 10, which actually talks about the splashdown. So the splashdown and the re-entry, which is actually the day. Talking about the splashdown, they actually hit the Earth about 40,000 kilometers per hour. So imagine a speed of 40,000 kilometers per hour. That you should know that is more like it's even more tense. It's even more tense, like more intense than coming. So, but just imagine 40,000 kilometers per hour. So do you know the kind of speed that is, right? That is more like the speed of a sound, or I don't know if you're actually getting it right now. I think that speed should be more than the bullet train in China. Yeah, definitely, because something actually at that moment, you know what gravity can actually do to such speed, and how you can actually influence such speed, right? So temperature rise to thousands of degrees. Like it was so hot. So I don't know if you get me now. It was so hot because you know the temperature is going to increase definitely. There was actually heat sheet for the spacecraft, like to protect the astronaut from, they actually get prepared for the whole thing. Then suddenly, parachute actually deploys and slide down in the ocean, and that was actually how there was actually a mission complete. So the splashdown actually took place at the Pacific Ocean, right? But most of the question people keep asking is, how did they get to know the exact location they're going to splash down? How were they able to like feel or eat, I think there were a lot of question, controversies in the comment section, like going through the international news channels, all that. Going to the comment section, it was so controversial that people were now doubting. But what I keep asking myself is, now, if we are doubting this whole scenario and this whole successful mission till now, like, what's the next generation going to think about this mission? Because I'm pretty sure definitely same thing happened in the first mission and this is the second mission. So tell me what you think in the comment section, and if you found this video helpful, kindly subscribe, give me a follow, and thank you. You can share with someone as well to know what actually happened within these 10 days. Maybe people that were unable to like meet up this review with this video, and I hope if you wish to understand what actually happened from day 1 to the 10th. If you enjoyed this breakdown, don't forget to subscribe, because I'll be bringing you more insane tech and space content like this. So thank you for watching, and if you love this, subscribe, follow, like, share with someone. So thanks for watching. Merci beaucoup.